Okay, let's talk again about the intrapleural pressure, not to be confused with the intrapulmonary pressure. Again, intrapulmonary pressure was the pressure inside of the lungs, particularly in the alveoli, and we have to keep changing the difference between the intrapulmonary pressure. We have to make it either higher or lower than the atmospheric pressure for air to either go in or out. But we have another pressure that's very important here, and that's the pressure in the pleural cavity here, the space that's created between the visceral pleural membrane and the parietal pleural membrane, because this space right here is what allows the lungs to be able to have suction. So when the wall moves, then the suction here will act on this membrane, which will then cause the lung to move. So this membrane is adhering to the lung. So if I have a pressure difference between these two cavities, between the space in all of these and the space here, as long as I can keep a pressure difference between those two, that creates a suction effect. Now, what creates that cavity and that pressure difference is the fact that we have elasticity of the wall that has a tendency to want to move outward, and elasticity of the lung where it tends to want to move inward, especially when we're exhaling. And so even though they've exaggerated it tremendously in this picture, we still see that we have this space between that membrane and that it has its own pressure gradient. Now, one thing to understand is that we have to always have this pressure lower than that pressure. Remember, this pressure has to go above and below atmospheric pressure, but it doesn't matter whatever compared to atmospheric pressure. If this goes above atmospheric pressure, this is still a negative pressure. If this is below atmospheric pressure, this is even more negative. So, and again, why do we do that? Because it keeps a suction. So when this pulls outward, this will go outward. When this recoils due to the muscle contractions, then that recoils due to the muscle contraction. Because lungs do not have the ability to inflate and deflate on their own, we literally have to change their volume so their pressure changes. Now, if we measure the pressure that's in here, and again, notice 760 millimeters of mercury would be atmospheric pressure at sea level. There's a few places lower than sea level. The Dead Sea is one of them, but most places would be sea level or above. So this number could change, but so whatever the atmospheric pressure is, whether I'm on the top of a mountain or down at the beach, then we're going to give that atmospheric pressure, we're going to label it 0. And then we know that if we want air to come in, we've got to drop the pressure inside the lungs, so our pressure would drop. For air to go out, exhale, we have to raise the pressure. But that was the pulmonary pressure. Now we're talking about the intrapleural pressure, the pressure between these two sides of that membrane. Okay, so what we're going to see is that we literally are going to always be a negative pressure. It's always got to be below atmospheric pressure, and it even always has to be below whatever the intrapulmonary pressure is if we're going to maintain that suction. So the membranes will pull the lungs, whenever the muscles pull the body wall, because we have the parietal membrane adhering to that and the visceral membrane adhering to that, even though they're all part of one membrane. When this goes outward, then that suction causes this to pull this outward. When this goes inward, then that suction causes this to go inward. So they're going to follow the movement of the muscles, but only if we can maintain the suction. The suction will only be maintained if I keep a pressure difference between what's in here versus what's here. So notice here, we actually have -4. So we're going to start down here at a pressure of -4, again, which will be equivalent to whatever the atmospheric pressure is -4. Now notice we started at -4, okay? And now we're dropping it because remember, even when we were doing the intrapulmonary pressure, we dropped it first and then it rose back up. So we're literally dropping this. We're dropping this pressure even more negative. So as that went to -1, this went from -4 down to -6. Now notice right here, at this point was when our pulmonary pressure went back up to 0, where air was neither going in or out, but then we had to raise the pressure. We had to raise the pressure to +1. So when our pulmonary pressure is raising, our intrapleural pressure is also raising, but it's not going to a positive number. It's still in the negative, still in a negative numbers, but it is raising back up to where it started, just like this raised and then went back. So then this is going to go from -4 to -6. So in inspiration, it's going to go from a negative to more negative, and expiration is going to go from more negative to less negative, but never a positive pressure. Okay, so you can see again where it rises back up. Now, again, starts at, in inspiration, starts at -4. By the time we get ready to start exhaling, the intrapleural pressure is going to drop all the way down to -6. Okay, and then by the time we start we start exhaling, where we have to increase the pressure inside, then it's going to go from this negative pressure to a less negative pressure, as we see right here. Now, since this is always a negative pressure compared to what's outside, and it's always more negative compared to what's inside, that's a negative pressure. What if something penetrated this area here, and it's a negative pressure compared to outside? What if it did? What if we didn't even touch the lungs? What if we just penetrated this area right here? Then let me ask you, would air come in or would air go out? Well, if it's a negative pressure, meaning that pressure is higher out here, remember, diffusion tells us air always goes from high to low. So if something were to break penetrate this area and break this bond right here and have an opening where air could get in or out, air would certainly go in. And when air went in, that would cause this pressure to rise. And if this pressure rose, then we couldn't maintain that suction difference between these two areas. Therefore, this would collapse. So looking at our picture here and our picture there, again, notice here's the pleural cavity, but here's actually the parietal pleura next to the muscles. There's intercostal muscles and ribs. Okay, the visceral pleura would be next to the lung itself. So what happens if we penetrate that area? Because our pressure here is always more negative than even inside the lung, and always more negative than outside. So if we do penetrate that, then it's not that air will leave, it's air will actually try to go inside, which will cause that lung to collapse. Okay, here we see the air went in and it caused that lung, look at that lung compared to that one. That one is collapsed because something penetrated through there and air actually came in, interfered with the suction that was going on there and caused the lung to recoil inward and totally collapse. Now air can't go in or out of this lung because it doesn't really have the ability to move by itself. Fortunately, though, we don't just have one pleural membrane going over both lungs, but each lung has its own separate pleural membrane. So while one lung may collapse, fortunately the other lung, as long as something similar doesn't happen yet, it will stay inflated, which gives us a chance to survive. We call that pressure difference between the intrapulmonary pressure and the intrapleural pressure, we call it transpulmonary pressure. And it's the transpulmonary pressure that creates the suction that we need to adhere to both the back of the body wall and to the lungs. And that's literally what keeps the lungs inflated. So again, looking at our graphs here, here's our atmospheric pressure, which is the outside air pressure. 760 if we're at sea level, 0, no matter where we're at, we can call whatever atmospheric pressure is 0. Notice that here we're doing inspiration here, okay? And in inspiration, what's happening? We're lowering the pressure. As we lower the pressure in our tidal volume of breath, normal breath, air starts coming in. As we get more air in, though, the pressure starts rising again. So here's air coming in, it starts raising the pressure again until we're at this point here where we have no air going in or out because we're equal to atmospheric pressure. Okay, but as we continue to make the lungs smaller, now we make the lungs smaller, we increase the pressure, and notice as we increase the pressure, air starts leaving. Well, as air starts leaving, then the pressure starts dropping again till we get back to where we started. So again, here's our other factor in this. The other part of the transpulmonary pressure is the intrapleural pressure, the pressure between the pleural membranes. So again, notice that we're always negative. We're always below what's going on in the intrapulmonary. And whereas this is going from 0 to 1 back to 0, this is going from -4 to -6 during inspiration, and then from -6 back to -4, or, according to whatever the atmospheric pressure would be according to where we're at. But the bottom line is it's never a positive pressure. It's always below the intrapulmonary pressure and certainly always below the atmospheric pressure. So here we see in our tidal volume, our air actually being expired from the lungs while this is going on, because we increased the pressure, meaning we made the lungs smaller, meaning now we're pushing the air out of it. Now look at these steps, because one step leads to another in our explanation of what's happening here. Notice what has to happen first for breathing to take place. Well, because lungs don't have the ability to change their size by themselves, what changes size in the body are muscles. So what has to happen is the muscles have to actually contract. And of course, for a tidal volume, a normal volume of air, a normal breath, then the muscles we're using are the diaphragm and the external intercostal muscles. They contract, which makes the whole thorax bigger. Okay, now if the thorax is bigger, and notice what we're looking at here, we're working from the outside of the body finally to the inside. So what's the order of things that happen from the muscles all the way inside? Well, the muscles cause the whole thorax to increase. What we have next is, what do we have between the muscles and the lungs? Well, we have the intrapleural membrane, which means that this intrapleural pressure becomes more negative, okay? And then when that becomes more negative, that's actually what causes the lungs to expand because of the suction that it creates. Well, when the lungs expand, then the pressure inside of the lungs, when the lungs expand, the pressure inside of the lungs, that intrapulmonary pressure, becomes more negative, and then air starts flowing into the lungs. So notice again, there's a sequence of events. This causes this, which causes this, which causes that, which causes that, which causes that. We're working from outside to inside of the lungs. Okay? Now, just like we have these events occurring in inspiration, we're going to have almost the opposite events occurring in expiration. Instead of diaphragm and external muscles contracting, they're going to relax. So looking now at the events during expiration or exhaling, the events here, again, we're starting on the outside. Instead of diaphragm and external intercostal muscles contracting, since it's expiration, they need to relax, because relaxing makes the whole thoracic cavity smaller. And if it's smaller, then what's connected to it is going to get smaller. So what happens? What's the next layer after the muscles? Well, it's going to be the intrapleural membrane. So the intrapleural pressure between the visceral and parietal membranes, or I should say parietal and visceral membranes, to keep it in the right order, then that pressure becomes, as we see here, the pressure became less negative from -6 to back to -4. Okay, it's becoming less negative here. And of course, if that becomes less negative, then the lungs themselves recoil and get smaller. And if the lungs get smaller, that increases the pressure inside of them. Notice that's increasing the pressure inside of them. And of course, what that's going to create is this expiration tidal volume, where air then is going to flow out because everything's smaller and we've increased that pressure, so it pushes this out.
Graphs with the movements of the thoracic cavity during inspiration and expiration.
So always work your way from the outside to the inside, and understand one thing triggers the next thing.